Good morning, everybody, and let me welcome you to our webinar on machinery safety for maintenance technicians. My name is Christopher McCutcheon, and I am one of the senior trainers here at Pilz UK. The idea of this webinar is to give you all a taster into the new course that we have had approved by City and Guild, which is on machinery safety for maintenance technicians. Now, my background personally was in maintenance engineering before I joined Pilz UK to become a trainer, and I understand some of the difficulties that we can have as maintenance engineers whilst we're looking at machinery safety. So the idea behind the course is to kind of upskill and make people more aware of machinery safety when we're in maintenance roles. Now, my colleague Gary Carter is sitting in the chat room awaiting your questions. If you have any questions around anything in terms of what we're going to be talking about today, please feel free to ask Gary anything. The more difficult, the better, to be honest. Yeah, keep him on his toes. But yeah, also my colleague Jamie Thomas is in there as well. And again, if there's any questions that you have, please feel free to ask. If we can't answer the questions right away, we will get back to you within a short period of time with the answers. So yeah, please ask questions. That's the whole point of this, to be perfectly honest. So our recording of this will be available on our webinar channel for a few days. But yeah, as I say, we're going to go through some of the content that's in the course, just to give you guys a bit of a taster of what the course contains. So yeah, I suppose the real aim of this course is to introduce maintenance personnel to the world of machinery safety. Now, in my experience, I understood a lot of things around maintenance engineering, but didn't really understand why we did it. So I understand, the difference between single channel and dual channel, but I didn't understand where it come from. I understood why we wired certain circuits in certain colors, but again, didn't really understand where that came from. So the idea is to give a bit of an introduction into some of these standards that we can use to help us and assist us, but then what's the necessity for the standards as well. So we do touch a little bit on some of the laws and the directives that we have in the UK and in Europe as well. Now, with maintenance, as I'm sure we're aware of, the idea is to keep production running. That's what we're there for. We've often been referred to as the necessary evil as maintenance engineers. Yeah, they require us to be in place to make sure that we can keep productivity at a maximum. So the goal of this course really is to upskill maintenance staff on things like safety related controls, but also the types of faults that you may see on safety related controls as well. Predominantly, well, we do focus mainly on safety relays and the types of faults that you will get on safety relays and how we can fault find on those safety relays as well. Now, within the course, there is a practical element. As you'll see in the slides forthcoming, there is a real practical element. It's almost half the course. So the first half of it will be wiring up safety related controls to a schematic diagram, and then the next day doing some fault finding around some faults that we put onto the system, and see how the safety relays react and what they indicate to us. So first of all, we need to start with legislation and standards, because we need to understand what is the point of machinery safety. That's often a question that we get asked here at Pilz UK. Well, what's the point of it? Why do we do it? What's the necessity for it? Well, the reason that we do it is because, first of all, it's the law. Okay, we are legally bound to make sure that machines are safe and in safe working order for people to use. And this often encompasses maintenance engineers, maintenance technicians, or maintenance staff to make sure that equipment is at a safe level. We're leaving it in a safe state after we've gone in and done our tasks. So this is just a little slide here. This is in the course as well, but yeah, this is just a little slide here to give everybody an understanding of where these directives come from. Now, I suppose the burning question is, why are Pilz UK talking about European directives? And that's because when, or before Brexit, this is where we were, okay? We were bound by European directives. Since Brexit, obviously, we're going in our own direction slightly, but lots of those European laws are still in place in the UK, and we still use European harmonized standards to show a means of compliance. So that's why we keep this in here, and it's just for people to understand the process of how we go from, a directive to a UK-based law. Now, as I mentioned, the use of standards is really, really important. And if anybody's been on any webinars previously, you will know that we use this slide in almost all of them. it's one of our favorite slides that we have here at Pilz UK. So what we're showing you here is kind of the structure of standards. There's different types of standards that we have. So right at the top of our pyramid, or of our triangle, we have EN ISO 12100. Now, 12100 is a vastly important standard. It talks about risk assessment and risk reduction, okay? And it can apply to every machine. Every machine you can apply risk assessment to and risk reduction methodology. Now, within the course, we have a number of slides around risk assessment. And the idea is that we're not trying to get maintenance engineers to do risk assessments. That's not what it is. The idea is that they understand the process of going through a risk assessment as to why we select certain things to protect against hazards, such as guards, interlocks, light curtains, scanners, two-handed controls, all of those types of devices. So we then start to talk about the B-type standards. So we have B1 and B2. So B1 is general safety aspects, things like distances of guarding, which is 13857. Now, again, you may ask the question, why do engineers or maintenance staff need to know this? But if you do any modifications, if you perhaps, make any changes in the system, then you might move guards, you might adjust guards, you might, perhaps change the guards for a different type. You need to understand and make sure that those guards are far enough away. This is also made reference to in PUA as well, which we'll talk on a little later. 13849 is our safety related control standard. There is an alternative standard as well, which is 62061, but predominantly in our course, we focus on 13849. We feel that it's often used to describe safety systems within maintenance engineering. You'll hear a lot of, single channel, dual channel. That's really where that comes from. But what does that mean, and how do we know the difference between single channel and dual channel? So throughout the course, we go through a very small amount of 13849. We don't believe that we need to get into the depths of doing MTTFD calculations and diagnostic coverage calcs and things like that. But it's just to touch on and give an appreciation of safety-related controls, because ultimately, maintenance staff will be at the coalface of this, working with the single channel or dual channel systems that have been selected. So we do touch on it very briefly. We also talk a little bit around the different types of devices. So as you can see there, we've got 14120, which is the design and construction of fixed and movable guards. We'll talk a little bit about some of the requirements. And again, for maintenance staff, making sure that we're replacing bolts and screws with the correct ones so that they are removable with the use of a tool only. So we're not putting quick release fasteners in to make our jobs easier, or we're not putting slot head fixings in or anything like that. We also talk about emergency stop standards in the course as well, 13850. And again, some of those requirements are, red push button with the yellow background if it exists, and we go through some of the points that are in there. We then have C-type standards, and to be honest, on the course we don't really delve into the world of C-type standards, just because there's so many of them and there's so many different machines that we have in the machinery safety world. But it's just to have an appreciation for them and be aware that perhaps there are some C-type standards that you could look at if you are doing any maintenance tasks. There may be some C-type standards out there that can assist you. Okay, so yeah, as you can see there, we've got a selection 10218 for robots. We've got 204 30 for injection molding machines. We don't talk about a specific standard on this course, but we do give an appreciation for what C-type standards are and the necessity for a C-type standard. Also, the fact that they will take precedence and often deviate from the more generic B and A type standards. We do talk about this standard, however. Now, this is a British standard. This is BS 14200. It is also a relatively new standard, and anybody that's an avid viewer of our webinars will know that my colleague Alex Bryce did a fantastic webinar on this standard. So if anybody wants to go onto the go-to page and find that, it's really worth having a look at. Now, the standard itself, we touch on a little bit. Again, this standard predominantly is for those that are managing or advising the maintenance requirements for machinery. But we feel it's necessary to give an explanation of this as well. So what we're looking at here is after a machine is put into service, we're trying to make sure that it remains safe and is reliable and a good repair. Again, this really echoes the requirements that are in PUA in Regulation 5, which talks about maintenance as well. Now, this is a very useful table, actually. Having been in some, maintenance supervisory roles previously, I wish we'd have kind of looked at some maintenance tasks through these eyes, really. So, yeah, we need to identify the function of the machine. So what's the machine doing? Okay. And then does the failure have an effect on safety? So when we're looking at maintenance, if we don't maintain it, will it have an effect on safety? Yes or no? If it's yes, then it's significant in its priority. Yeah. So if something is going to fail, if we don't maintain it in a dangerous way, then we need to put that kind of top of the list, really. If that's a no, then we need to look at, does the failure have an effect on the reliability of the equipment? Does it affect productivity? And again, if that's a yes, then that needs to be prioritized next. Now, if that's two no's, then we reduce the priority. If it's something like going outside and cutting the grass outside the factory, that probably doesn't have an effect on those two things that we're talking about, okay? But when we're looking at reliability of things like safety-related controls, like guards, interlocks, sensors, these are crucial to safety. So we need to be functionally checking these to make sure they work. Now, speaking of functionally checking, you may do something like pre-startups, and that's something we're going to touch on in a little second. But yeah, we first of all need to determine that the maintenance approach, is it planned? Yeah, so are we going to plan it in to do preventative or predictive maintenance? Are we going to try to make sure it doesn't fail in advance? Is it going to be something that's more reactive, i.e. we're walking around the plant and we can hear, say, a bearing squealing. It's still running, but we know potentially that's going to fail. So, we're reacting to the physical environment that we're working in there. Or is it going to be a breakdown where actually the line is stopped and we have to, all hands to the deck and get in there and try and get it back up and running, okay? Now, as it mentions on the right-hand side to that, you can see things like the OEM's design life. So, yeah, often when we're determining our maintenance approach, we are reliant upon the manufacturer of the equipment to give us some information around, checking of bearings, lubrication, changing of parts and components. We'll often use that right at the start. We could do things like condition-based monitoring, and there's been some fantastic advancements in that technology over the recent years. So again, vibration monitoring, monitoring thermography, all of those, ultrasonic. I had a guy on a course the other week that was telling me about they do ultrasonic checks. So yeah, lots and lots of good condition-based monitoring. So yeah, this standard gives us a bit of advice on, the types of approaches that we can do. When we're looking at things like pre-use checks, we'll delve into some of them again in a few minutes. But yeah, pre-startup checks, checking your e-stops, making sure your start-stop controls are okay, making sure the general environment and the machine is actually okay to run in a safe way. Again, periodic inspections. This is where, we're going to be going to the machine at regular intervals, maybe doing a little bit more than a pre-use check and perhaps a little bit more than routine servicing. We're maybe doing a bit more of a deep dive, taking some bits off, making sure, things haven't worn. Whereas routine servicing is more like your lubrication, topping up your oil, lubricating your bearings, those types of things. Again, we can have our own formal periodic reviews of maintenance. So collecting data, checking to make sure that, things aren't failing before we're maintaining them. Because if that's the case, we're getting breakdowns, we're losing time, it's not going to be great in terms of productivity. So we might want to look at collecting data and perhaps using that as the basis of our maintenance planning. Yeah, this slide just kind of gives us an understanding of the different approaches to maintenance and definitions of this. So yeah, I'm not going to read these out to you guys. You can see them there, but it does look at things like plan preventative, plan predictive, reactive, as we said. So, we can respond to the events, as I say, squealing bearings or something along those lines. And then, as I say, breakdown, which is a reaction to the failure, complete stopping of the line or something along those lines. Then we've got our sort of different tasks we can carry out here. So as I said, pre-use, daily checks, these can often be done by machine operators or line leaders or team leaders, and from a production perspective, not necessarily always done by maintenance staff, but again, they are maintenance tasks. So it might be done every day, it might be done at every shift, often prior to the machine's operation. So again, it can just be a visual check. You might just walk around, make sure everything looks okay, make sure we're okay to start up, or we might do functional checks. We might actually open the guard doors and make sure that they reset when we close them. It might be pressing the emergency stops to make sure the system stops. So again, all dependent upon the OEM's designation, really. Yeah, periodic inspection. In addition to these, as I say, a little bit more deep dive. We might have to dismantle some parts of the machine, identify required repairs, and then report any repairs that we've done. And then our routine servicing, sort of cleaning, adjustments, topping up fluids, all the rest of it. Yeah. As I mentioned, 12100 is a really, really important standard. Really important standard. So it's the building block of everything we do in machinery safety, because it's all about risk assessment and risk reduction. Okay. Now, I want to be quite clear on this, and I'm sure this has been emphasized in other webinars as well. 12100 does not give us a methodology on risk assessment. It does not say in this scenario use a risk matrix. In that scenario, use a hazard rated number or a risk graph or a multitude or a hybrid of those methods. It doesn't give us a methodology. What it does do is gives us a flow to follow, a process to kind of follow step by step in order to do a risk assessment confidently and correctly. It also gives us some basic terminology as well. So it tells us what is a hazard, what is a risk, what's a danger zone, what's an exposed person, what's an operator. So it does give us some terminology which helps us to interpret the essential requirements that we can find in legislation. So yeah, what is a risk assessment then? So it's a series of logical steps that allows us in a systematic way to examine the risks that are associated with machinery. When we do our risk assessment, we then look at risk reducing as described in this standard. So the purpose of the risk assessment is to identify any hazards, estimate the level of risk. This is where your methodology comes in. So yeah, you'll first identify the hazards. Again, we often suggest that risk assessment should be done as a team. Okay, so that we've got people from different backgrounds with perhaps different specialized skills in order to understand the risks that we face. This is often where maintenance staff will be included, because maintenance staff, their job is to find faults and work with electrical and mechanical systems. So yeah, you may be included as maintenance staff in identification of the hazards and perhaps the estimation of the risk. And as I say, the estimation of the risk is where we use our methodology. We then need to evaluate that score, that color, that number that we've give to that hazard. So evaluation is a very important part. Is it acceptable? Now, every business, every industry has a different level of acceptable risk. And again, that's not for us to dictate that to you. That's for you as a business to set your stall out there. Then we need to look at if that risk is not acceptable, we then reduce it in accordance with the practices that are in the 12100 standard. So in terms of reducing risk, there's a 3-step method that we use. First of all, we design the hazard out. So elimination by inherent safe design is step 1. So can we design that hazard out? Now, often in maintenance and in operations where we already have the machine, that's very, very difficult to do, okay? The machine's already been designed by the OEM, and designing out the hazard can be quite difficult, time-consuming and costly. The next step is engineering controls. So this is guarding, this is light curtains, scanners, pressure mats, two-handed controls, radar, interlocks, all of these things. Then the third step is information for use. So this includes warning signs, training, procedures, safe systems of work, all of these things. Now, the idea is that we're trying to reduce the risk to as low as we possibly can. We then go back round this flow chart that we've just been talking about to make sure that we haven't created any new hazards via our risk reduction, or we haven't increased the risk of an existing hazard. And you can go back round that a couple of times. Now, again, you may be thinking, well, why are we talking about risk assessment? You know, we're end users. This is mainly aimed at OEMs. We don't really have to consider this. Well, actually, we do. Because yes, you are right. You know, in the Machinery Directive, which is the current law that we have in Europe, which is transposed in the UK as the Supply Machinery Safety Regulations, it states in here that manufacturers of machinery or their authorised representatives must ensure a risk assessment is carried out. We also have the Use of Work Equipment Directive in Europe, which in the UK we transpose as PUA, the Provision and Use of Work Equipment Regulations. And again, in here, the emphasis is on the employer to make sure that a risk assessment is carried out in order to make sure that the equipment is safe for use for their employees. So yes, in some respects, we might think that risk assessment only applies to OEMs, but actually it doesn't. It applies to both sides of the machinery safety fence, machine builders and end users. Now, we mentioned the risk reduction part of risk assessment. And, you know, particularly in step 2, I was talking about things like light curtains, interlocks, scanners, pressure mats, two-handed controls, you know, all of these types of devices. Now, those devices require a control system. And where it requires a control system, we have to look at our safety-related control standards. Now, as I previously mentioned, there are 2. There's 13849 Part 1 and there's 62061. We focus predominantly on 13849. Out of the 2 standards, in my experience, is a little easier for people to get their heads around 13849, okay? And commonly they'll be familiar with things like performance levels. They may have heard that phrase performance level before. So in the course, we don't spend, you know, all day learning about MTTFDE and diagnostic coverage and, you know, all of the categories and the intrinsicness of all of that, but we do touch on it because we need to understand why. Why is this dual channel? What is the purpose of dual channel? What does, you know, what is the difference between a category 4 system and a category 2 system? We need to know that because when we're fault finding, you know, we might do something where perhaps we make a mistake and we've now changed the category and it's not detecting, you know, the short circuits that we previously thought it was. So again, having an awareness of this, we believe is very beneficial for maintenance staff. Now, what you'll see here is a couple of things that are in the course. So on the left-hand side, you will see figure 5, which is from 13849. Now, I affectionately like to call this the reggae chart because we've colored it in here. So it's got some nice colors, which make it a little easier to follow. But yeah, we go through the explanation of what's in figure 5, okay? And we explain, you know, the categories. It's about, I suppose, like a jigsaw piece. To get to the performance levels, we need to look at the categories, we need to look at diagnostic coverage, and we need to look at the reliability of the components, which is the mean time to dangerous failure. We also bring up this table, which is on the right-hand side, and this is a really useful table. You know, I'm a big fan of this because it shows you each of the categories, their description, whether they're single channel or redundant or dual channel, and some of the requirements around, you know, mean time to dangerous failure, which is, as I said, reliability of components, or diagnostic coverage, the ability for the system to diagnose a fault. And to be honest, that's kind of the depths of what we get into. We do go through the categories in a practical example when we do the course. And the reason we do this is because the delegates will wire up to certain categories. Okay, so we do get the delegates to wire a category 2 system, a category 3 system, and a category 4 system. We also talk about this standard, 60204, which is the safety of machinery, electrical equipment of machine standard. Now, 60204 is a standard that's used throughout machinery safety. Almost all equipment has some form of electrical or electronic devices on them. So the idea of the standard is it looks at the safety of persons and property, consistency of control, and again, ease of operation and maintenance. So it does make reference to maintenance. Now, in my experience, having worked in industry for a number of years, a lot of people don't know about 60204 when they're maintaining equipment. Often they will refer to, in the UK, what we call 18th edition, or BS 7671. Now, BS 7671 is, you know, it is a standard and it's a very good qualification to have 18th edition, but that's predominantly aimed at electrical installations, whereas 60204 is about electrical safety of machinery, specific to machines, okay? So in here, it gives us things like wire colors. It tells us about accepted circuits, things that remain live after isolation. It talks about direct and indirect contact and how we protect against that. It talks about SELV and PELV, and you know, it's a huge standard, really important standard if you are from a maintenance background. So yeah, it does look at equipment that has a voltage range of 0 to 1000 volts AC and 0 to 1500 volts DC, okay? And we go through quite a lot of slides on 60204 because, again, we feel it's necessary to expose people to this standard because, as I say, in my experience, not a lot of people are aware of it. So, yeah, we go through, you know, probably about 40 slides on 60204 within the course. So we then get into a little bit of the practical wiring. And this is, to be honest, this is the bit that the delegates really enjoy. Because, yes, you know, as I said, it's very important to understand the legislation and the standards that assist us. But as maintenance staff, we want to wire things up. We want to make things work, make things come in and out, get some lights flashing and all the rest of it. So, yeah, it is in the few courses we've ran already, this is the bit that people really like. So what we do is we guide the delegates through how to wire up certain categories. Now, they will work to a schematic diagram, okay? But we also go through the process of explaining the different parts of the operation manual, such as the mode selector setting. So, you know, are we with detection of shorts or without? And again, as you can see here, to wire up a safety relay, you have to understand what with detection of shorts and without detection of shorts actually means. So that's where the emphasis of understanding 13849 comes from, okay? Now, within the course, we look at a number of different starting or restarting settings. So the category 2 and category 3 system will be automatic, monitored start with falling edge, and the category 4 system will be an automatic start, okay? We do also show the functionality of a automatic start with the startup test just after the guys have wired it up. So again, it's just to show the capabilities of the safety relay. We then explain what this actually means when you look in the operations manual for your devices. So as you can see on the left-hand side, it shows you your input circuitry. So what are you trying to wire? Is it an e-stop? Is it an e-stop that's single channel or dual channel? You know, is it without detection of shorts? Is it with detection of shorts? Is it a safety gate? Is it an OSSD device, such as a light beam or perhaps an RFID switch, which is actually part of the course? You do wire an OSSD device as a category 4 system. So again, we go through the explanation of what is actually in the manuals and how that relates to the devices that you will have on your machinery. We also look at the output system. So we look at with or without feedback loop monitoring. And again, the emphasis here is from 13849. Do we have to check the feedback loop? Well, for most machines, yes, we probably will. Okay, but maybe we don't. It all depends on what has been selected. Okay, and again, this relates to the automatic start or the monitored manual start, which is essentially with a reset button. Okay. So yeah, in terms of fault finding, again, we go through with the delegates what's in the manual. So yeah, believe it or not, we actually do indicate how faults happen. So if certain things are flashing at you, that means we have to look at something. So for example, if IN1 flashes and IN2 stays solid, then we need to look at the fault which is on IN2. Yeah, so the light that flashes at you is just indicating I'm healthy, but the other one isn't, for example. Now, this next slide is quite interesting. I'm going to be honest, in the few courses that we've ran already, this is how most people are wiring up the controllers, okay? This is what we're seeing on most bases, but what we're showing you here is this is the boards that the guys will work to. So a couple of control contactors, and then we've got a contactor that drives a fan. We've got 3 safety relays, and we've got 3 safety functions. So one safety function is an emergency stop system. The other safety function is a mechanical locking device, a guard switch. And then the third safety function is an RFID switch, okay? So the delegates will work to a schematic, okay? Now, they don't have to draw anything out. They don't have to, do it themselves. The schematic is there just for them to follow. But yeah, it's just to give you an appreciation of actually what the practical side of it looks like. And yeah, if we can avoid wiring it up like this, it makes it a lot easier for me if there's any problems to fault find. We did have one particular delegate. I won't mention him by name, but he was actually the apprentice of a business that we went to, and he wired his system like this. Absolutely fantastic. So yeah, he went, through the heartache of putting it in the trunk in and making sure everything was all nice and color coordinated and everything else. But yeah, essentially, guys, the idea behind the course is to give maintenance engineers to upskill, to make, engineers more aware of safety related controls and machinery safety. So yeah, it's just for me to say thank you very much for spending some time to listen to me talk about this course. It was developed between myself and a number of colleagues here at Pilz UK. So yeah, thank you very much for spending the time to listen to us today. And if you have any questions, please forward them to Gary and Jamie that are in the chat. And yeah, thank you all very much.